Okay, so we're starting, this is the second part of this geometry unit, and it's on transformations. Your objective or your standard is to verify experimentally the properties of rotations, reflections, and translations. Okay, so your objective is I can understand the characteristics of transformations. Your sub-objective is you need to know how to find ordered pairs on a coordinate plane. So it means we have to go back to being able to read a coordinate plane. We have to find our ordered pairs. So we find our x and then we find our y. We have to know the positive and negative sections on a coordinate plane. What side is positive, what side is negative. And we need to understand the difference between a pre-image versus an image. Okay, and then you also need to know what a prime letter means. Okay, so basics of transformations. To transform a shape or a figure means to change it. So to transform a shape or a figure, it means to change it. In general, we change the size, location, and direction that a figure is facing. So a figure is going to be some sort of shape on a coordinate plane. It could be a square, it could be a triangle, it could be a rectangle, it could be a hexagon. It's going to be any kind of shape, okay? So like I just said, in general, we can change the size, location, and direction of the figure. The shape of the figure before the transformation is called the pre-image. Okay, it's called the pre-image or original. Okay, but you're going to hear us talk about it as the pre-image. Okay, so pre means before. We might label it A. Okay, so we might label that pre-image as A. The shape or a figure after the transformation is called an image or a new figure. We would then label it A prime, pronounced A prime. Do you see the little parentheses behind the A where it says labeled it as A? You see the parentheses? Not the parentheses, the apostrophe sign. That means prime. Okay? Okay, so these are the type of transformations we're going to look at over this week and next week, okay? So the first type that we're going to look at is called a translation, okay? It is called a translation. And the key, so you have your pre-image. You see your smiley face with the A. That is called your pre-image. And then you have your image, which is your A prime. Notice it has moved on the coordinate plane. So a translation is often called a slide. So you might slide to the right or slide to the left. Or you might slide up and then slide to the left. Okay? So a translation is known as a slide. You're sliding a figure along a coordinate plane. Okay? The second one we have here is reflection. Okay? And notice we have our pre-image and then we have our image. Okay? Look at them. Notice the face. What do we notice about the little on the smiley face, the black part of the eye? What do we notice? Has it moved? No. Does it look like it's on a different side of the face? Yeah, so it's a reflection. You know when you look in a mirror, everything that is over here on your right, when you look in the mirror, is now on your left. Okay? So reflection, another term you'll see, is called flip or mirror image. Okay? So, our third type of transformation is called a rotation. So, it's called rotations. So, you're going to be rotating figures. So, we have our pre-image and our image. Okay? So that image is rotated 90 degrees clockwise. So you'll have images that are rotated 90 degrees, 180 degrees, and 270 degrees. They'll either be rotated clockwise or counterclockwise. Okay?
And we understand what clockwise and counterclockwise is?
So if you look at a clock,
We're going this direction to the right.
yeah,
If we're going counterclockwise, we're going to the left.
okay? So, the next one is called dilations. You have dilations. So we have our pre-image, we have our image, and then a dilation is either an enlargement or reduce. Okay? And I've got another slide that we're going to look at that shows you real world images of all of these things, okay? So we have a translation, which is a slide, a reflection, which is a flip, a rotation, which is a turn, and a dilation, which means to enlarge or reduce a figure. So I'm going to show you a video real quick, and it kind of puts this into a corny scenario for you. I need to stop it because...
Transformation style. Transformation style. Standing at the origin, flipping upside down. Minutes into reflection, spun it round. Right angle, that's rotation. That is rotation. Right, Transformation style. Transformation style. Transformation style. Transformation style. Reflection, translation, rotation, transformation style. Reflection, translation, rotation, upside down, it's a reflection, spun it round, 360 degrees, that's a rotation. Side to guide, 5 to you, left to the right, yeah, side to guide, 3 units of my tell. Side to guide, that's for the translation, flip spin, side down, you know my.
Okay, so where do we see transformations in the real world? List some examples below. I'm going to give you something. I'm going to give you an example, and then you can give me an example afterwards, okay? So translation. We said that translation was a slide, okay? So something that you might see in the real world would be a conveyor belt. It's sliding, okay? TJ said a slip and slide, okay? What is a dance that they do in country western bars that a bunch of people get up and do?
Because a lot of them visit country western bars.
Yeah. Well, what's a dance when you go to a dance that people do in a line?
This is the one I really
They do what?
Cha-cha slide.
Huh?
Square dance?
No, the cha-cha slide or the electric slide. Those. So how many times are you sliding to the left? You're sliding to the right.
Every wedding I've been to in the last 10 years has played that stupid cha-cha slide.
Okay. So.
Every dance we go to.
Oh,
So.
it hurts me every time.
Reflections. So a reflection is the image of a landscape on the body of water. That is a reflection.
Most of you should see one every day.
Yeah, hopefully. Please.
Oh,
Everybody should be looking in the mirror at least once before they leave the building or the house.
or your window.
Yeah.
Because I often use my sliding glass door on the way out.
Rotations is a wheel. A wheel is constantly rotating. Okay? It rotates further than what we're going to rotate, but a wheel is constantly rotating. Anybody think of anything else? What are those big, huge things that they have out in the, I think we have one over there right past the bridge if you're going to UT, and there's a big wind farm where they have windmills. That's rotating. Okay?
Somebody doing cartwheels across the...
Yeah, somebody doing
amazing
cartwheels.
floor. Or flips.
So dilation. Think of your pupils. You know, when you come into a building or you leave a building, your eyes dilate based off of the amount of sunlight you're getting. So you have a dilation where it's larger, or you have one where it gets smaller. Okay. So the obviously the bottom picture is where the dilation is bigger, right? And the top picture is where the dilation is reduced. Okay. Okay, if a transformation preserves congruence means that it's equal or keeps the same size and shape of a figure, it is called a rigid transformation. If it keeps the same size and same shape, it is called a rigid transformation. We all know that congruence means equal, the same. A transformation might also change the way a shape is facing or its orientation. Okay? We all know that when we started the 6th grade, you had an orientation day. When you start the 9th grade, you'll have an orientation day. It's the start of something. Okay? Maybe it's the original facing.
And if you choose to go to college, you will have an orientation to college.
Right.
Or you have an orientation for a new job. So when I started here in Knox County, I had a week-long orientation. And they had to go over everything that they wanted us to know to be successful here in Knox County, such as making sure that I get all my benefits, making sure I get paid right, making sure that I know where things are. Okay, it's making the beginning.
So, label the type of transformation shown, then state whether the size and orientation changed or stayed the same. So, let's look at number 1. So, what do we think number 1 is doing?
Why is it a reflection?
Because everything switched size, didn't it? So, did the size change?
No.
It stayed the same. Did the orientation change?
Yes.
Yes, it changed because it flipped sides. Okay? Because you can see the 2 little dots in the lens. You can see that they've changed directions. Okay. Number 2, we have dilation.
The size.
Did the size change?
Yeah.
I accidentally hit the button too soon. I gave you the answer. Did the orientation change? No, it stayed the same. So what do we think 3 is? A rotation, yes. And a rotation, did it change sizes? No. Did it change direction?
Yes.
Yeah, it changed. So number 4, what do we think 4 is? Think it's a reflection?
It's a what?
It's a translation.
It is a translation. It slid. Notice everything is the same on it. So the size is what?
The same.
The same. Is the orientation the same? Yes. So keep those in mind. So when you have a reflection, the size is going to stay the same and the orientation is going to change. When you have a dilation, the size is going to change and the orientation is going to stay the same. When you have a rotation, the size is the same, the orientation is changed. And the translation, everything stays the same, the size and its orientation. Okay? So notice out of all of these, the only one that size changes dilation. Okay? The only one that orientation changed the same or stayed the same was a translation and a dilation. Okay? Does anybody have any questions so far?
Everybody's got this down? So we're going to use the graph to identify which type of transformation is shown by the following figures. So we want to look at figure A and then look at figure B. So we look at figure A and then look at figure B. What happened from figure A to figure B?
So figure A to figure B is a reflection. So look at figure B and look at figure C. What did it do? It rotated, didn't it? Okay. How many degrees, just, we haven't talked about this, but how many degrees do you think it rotated? If you have a 90 degree, a 180 degree, just think about those two. Yeah, it rotated 90 degrees, which is just kind of a half of a rotation. And figure C and figure D, what did they do? What?
Translation.
It's a translation. It's a slide. And figure D and figure E, what? It's a dilation. So, summarizing today's lesson by answering the following: what type of transformations are rigid transformations? Do we remember?
If it keeps the same size and shape.
What type?
So a translation.
A translation?
What else?
Remember, a rigid means that the size and the shape did not change.
Reflection.
Okay.
Is there another one? Rotation. And a rotation. Okay. All three of those.
So reflections, translations, and rotations, because they do not change the size of a figure. So how can you tell on a graph?
Write it down.
How can you tell in a graph which figure is the pre-image? Which one is the pre-image? Is it the first one or the second one? The first one, isn't it? So a pre-image will not have it also, we didn't say this, but a pre-image will also not have a prime notation. Remember we said that the notation was the apostrophe sign? So we said that if the image was labeled A, the pre-image is A, then the image is going to be noted with an apostrophe. What is meant by the orientation of a figure? What did we say was meant by an orientation of a figure? We said it's the way the shape is facing or the order of the vertices. The vertices is, think about the vertex, it's the center, okay? When we talked about angles, the two angles that shared the vertex, it shares the vertices, so it's the center. And the last one is, what type of transformation affect the size of a figure? Only a dilation affects the size of a figure. Okay, so your homework agenda says on page 2 and 3 to do problems 1 through 10. That is your homework for tonight, to do problems 1 through 10. Okay, we're going to check that tomorrow in class.